You are welcome to online lectures with from Eternity the School Board. Today we take a look at physics and we have a question on the board. The question says, an elastic material of length 3 meters is to be stretched to produce an extension 3 times its original length. Calculate the force required to produce the extension if the force constant of the material is 982.3 Newton per meter. The question source is 2020 WASSCE, West African Senior Secondary School Examination, Physics, Theory Question 1. Okay, this question talks about elasticity, and specifically Hooke's law. For us to be able to answer this question, we should know Hooke's law. So, what does Hooke's law say? Hooke's law states that provided that the elastic limit of an elastic material is not exceeded, the extension produced is directly proportional to the load or the force applied on the elastic material. So if you have an elastic material, the more force you apply on the elastic material, the more extension, the length will increase, provided that the elastic limit is not exceeded, because every elastic material, they have their own elastic limit, the point at which they will not extend further. In fact, they may even get to a yielding point and the yield point and the breaking point. So let us not go there. But the point is that provided that this point is not exceeded, the more you apply force, the more the length increase, so the more extension. So with that Hooke's law, we will be able to solve this question. So Hooke's law, from what I stated now, Hooke's law states that F is directly proportional to E. F is the applied force or the load, while E is the extension. Extension and the length are not the same thing. So if you want to check the extension, you do a extension. Extension is simply the difference between the original, the final length, the length produced when you apply the force, minus, as I said, the extension and the length of the material are not the same thing. Extension is simply the difference between the length produced when you apply the force minus the original length of the material. So this difference will give you the extension. So they're not the same thing. There are some questions you will see, they may want you to determine the extension. Are we together? There are some questions you will see, you may have to determine the word extension. So let us have that at the back of our mind, that the extension and the length of the material, they are not the same thing. That's why here you see the length of the material and you see the extension. They're not the same thing. All right, so let's continue. So this one doesn't require us to start doing the difference between the original length and the final length when you apply, because if the length is this and you apply a force, it will extend. So that difference is the extension. Okay, now let's look at the question. Let's now solve the question. So if F is directly proportional to E, so that means F is equal to what? KE. So we put a constant to remove this sign of proportionality. There should be a constant, and this constant is what we know as the force constant. This constant is a force constant, because if you see the unit Newton per meter, and if you want to find this K now, it's simply K is equal to F over what? Extension. F is Newton, force is Newton, extension is meter. So that's why the unit is Newton per meter. All right, so let's continue. So now let us now solve the question. From the question, the force is what we are looking for. We don't know the force. The force constant K is equal to 982.3 Newton per meter. Now, we are told from the question that extension is that the stretch to produce an extension 3 times its original length. So extension is equal to 3 times what? Original length. But the original length is equal to what? Call it LO. The LO, which is original length, is what? 3 meters. See it here. So that means that extension is equal to 3 times 3 meters, sorry. 3 times 3 meters, which is what? 9 meters. So the extension is what? 9 meters. So we can now find the force, applied force. So F is equal to the force constant, which is 982.3 Newton per meter, times the extension, which is 9 meter. So this place F is now equal to this. Once this meter multiply this per meter, they will cancel each other. So N will stand out. Let's go. 9 times this 3 here for the decimal point. We have 227. Okay. So you put 7. The 2 will come over here. 9 times 2 is 18 plus 2 is 20. Decimal point will come down. 20. You put the 0. The 2 should come here. 9 times 8. 8 times 8 is 64. Plus another 8 is 72. 72 plus 2 is 74. So we have 4. Get the 7 here. 9 times 9 is 81. 81 plus 7 is 88. So put down 88 here. So the force required to produce this extension is 8,840.7 Newton. That is the force required to produce the extension. So that's the answer to 2020 West Africa Senior Secondary School Certificate Examination Physics Theory Question 1. Thank you very much for your attention. If you have any question, feel free to drop the question on the comment section, and by God's grace, I will attend to the question. Please subscribe to my YouTube channel and my Facebook page. My YouTube channel is From Eternity, the Schoolboy. Also follow my Facebook page, From Eternity, the Schoolboy TV. Sorry, YouTube and Facebook pages, From Eternity, the Schoolboy TV. You can also follow me on my profile, which is Pharmacist Isaiah Emmanuel Chetana, in bracket, From Eternity, the Schoolboy. That's the profile you are watching this lecture now on Facebook. And on YouTube, you are watching it right simultaneously on From Eternity, the Schoolboy TV. By God's grace, with time we add other platforms where you can be watching this lecture streaming live simultaneously. Please share this lecture, like this lecture, share with your friends, share with your colleagues, your children, and your students. Someone out there may be in need of these lectures, and God will bless you as you do so. Please don't leave. Please, we are coming back again for another question on physics, and God will bless you as you wait. See you when we come live again.